Okay, we are going to get started. Thanks everyone for coming. My name is Ara Pulido. I work at a company called Bitnami as engineering manager. And for the next few minutes, what I'm going to be talking about is the service catalog and how, as an app developer, you can use it to connect managed cloud services with your Kubernetes applications. So the way I'm going to do this thing is I'm going to spend about 10 minutes explaining very briefly what the service catalog is and how it looks like. And then I'm going to do a demo that I'm going to hopefully show 4 different examples on applications that use the service catalog to connect to those services. The examples are using Helm Charts. Helm is a package manager for Kubernetes. But even if you're not familiar with Helm, the format is basically Go templating on YAML, so you can follow along because it's basically YAML. But first, who we are at Bitnami. So we are leaders in application packaging. We have more than 400 applications packaged for the different cloud providers. So basically, if you go to AWS Marketplace or GCP Marketplace, and you want to spin up a cloud image running WordPress, for example, out of the box, that image may be ours. And that catalog of applications we also offer as containers and Helm Charts. So we actually maintain many of the community repo Helm Charts. And our containers are updated on a daily basis or rebuilt, so they're up to date for security issues. On this application wall, we also do a lot of open source projects on the application space in Kubernetes, like Kubeapps, which is a Kubernetes dashboard, application dashboard for your cluster, the Kubernetes production runtime, Seal secrets, kubeless, and other stuff. I'll be showing a little bit Kubeapps during this talk. But first, why we need managed services. So we all know that Kubernetes is great to run your applications that run in containers in production. But one of the great benefits of being really cloud native is that you can use also these services that this cloud provides, and they manage themselves. So you really can focus. You can focus on what makes your application, what provides value to your business, rather than having to provide all this plumbing for your application. So for example, if your application needs a database or a PubSub queue or storage, a bucket storage, instead, obviously, you can create that yourself, provision that yourself in your cluster, maintain it, do it backups, HA, all these things. Or you could use one of these services coming from these clouds, and they do all of that for you. They can offer multi-region, auto-scaling. They can offer, obviously, backups for your databases. And the problem is the disconnect between your Kubernetes application and those services. So maybe you have to go to these cloud UIs and provision one of these services, or using the CLI, or using the API, or using something like Terraform you can use as well. But then you have to really connect that to your application. You have to create your secrets in Kubernetes yourself to connect to that app, or use external service. So the thing is that this breaks the declarative model in Kubernetes, where the goal is that you can describe your application, how it has to look like, and Kubernetes does all the thing for you on the reconciliation loop. So the service catalog basically tries to solve that. So it's a declarative Kubernetes API extension to discover and manage services that implements the Open Service Broker API. So the Open Service Broker API is a standard, it's a schema. It was originally created for the Cloud Foundry, but now it has implementations also for Kubernetes and OpenShift. And it's a super basic API. It doesn't have that many objects. So this is more or less how it looks like. At the bottom, you have the service broker, which is the abstraction of the service provider. So you can have a service broker for GCP, one for AWS, one for Azure. or even for your own cluster. So if you want to, as part of your infrastructure, you want to offer services that are on your infrastructure using the same API, you can basically implement a service broker yourself. On top of that, you have different service classes, which is the representation of these services. So for example, you can have a service class could be Azure, Postgres, or GCP storage, or AWS RDS. All of that are the classes. And for each of the classes, a broker needs to implement one or many plans. So, and the plan tries to abstract the idea of the different tiers of these services. So for example, you can have a basic plan that it also have only one instance, and it's very small, with very little CPU and very little RAM. And then you can, obviously with a low price point, and then going up to a bigger instance, or many instances, or many regions. So all of that are the service plans. Up to that level, those service broker, service class, and service plan are cluster level objects. So it has to be a cluster admin who deploys that into the cluster, and they're available cluster-wide. And then we have service instance and service binding. So those two objects are namespaced, and usually a developer who wants to use one of these services, what they would do is to create one of these service instance objects, and the service catalog controller will talk to the service broker and provision that instance for them. And service binding is tries to describe the connection between your application and a service instance. And that takes the form of a secret, a Kubernetes secret, that then you can use in your application. So a very simple API. One of the important things here is that it's basically a declarative Kubernetes API extension. So you can describe your full application just with some more objects, and Kubernetes will do the right thing. So these are a couple of examples just to see that these objects really look like any other Kubernetes objects. This is the cluster service broker for GCP and Azure. You have your API version, your kind, some metadata. And then it's super simple. You just have an endpoint, a URL that talks to that service provider, and some auth. Obviously, you have to have your credentials somewhere to basically to your project in GCP, with your subscription in Azure. But you can see that these are very different implementations. If you realize the GCP URL is pointing to Google itself, so it runs, the broker runs on your project in GCP. In the Azure case, you can see it's a service running on your cluster. So if you want to provide to your users, your cluster users, you want to provide Azure, you need to create a deployment, and the broker will run as a pod in your cluster. So when the cluster operator creates one of these resources, basically what it happens is it connects to the end. The controller will talk to that endpoint. And if you have permissions to do so, it will retrieve a list of available services and plans. And it will create all these cluster service classes resources and cluster service plans, again, at a cluster level. And this is a couple of examples of these classes. One is Google Storage. The other one is the Azure database for Postgres SQL. And one of the, as you can see, it doesn't matter what type of class it is. The object looks very similar. So you don't need to know these things beforehand. Another way to interact, I'm going to be showing during the demo a couple of tools, so I want to show them here. One tool is SVCat. It's in the same repo as the service catalog. It's basically an official CLI tool for the service catalog. It's great for testing. So It basically allows you to do things like get brokers, get classes, get instances. All those things, obviously, you can do with kubectl as any other object, but the formatting of the output is a little bit better. But also, it allows you to provision your instances without having to be declarative. So it's a good way to try, if you want to test that you can actually provision an instance, that you're giving it the right parameters. All of that is a very quick way to give it a try. And as I said, we are going to be using Kubeapps during the demo as well. It's an application dashboard for your Kubernetes cluster that shows the Helm applications that you have, catalog. It has service catalog integration as well. And I'm not going to be talking a lot or at all about Kubeapps, but it provides a nice UI, so it's easy to follow the demo along. So that's for before the demo. So as I said, I'm going to be showing 4 different applications. Those are open source application packaged as Helm Charts, and they connect to the service broker in 4 different ways, or 3 different ways. So my demo expects Wi-Fi to work, so let's hope that happens. So I'm running a 5-node GKE cluster. I have the service catalog running, so you have the API server and then the controller. As you can see, it's an API server, so it's not a CRD, which may or may not be a good idea, but that's how it is. I have Kubeapps running with a lot of sync jobs. And I have a couple of brokers deploying my cluster, so the GCP broker and the Open Service broker for Azure. Both are on a ready status, so that means that I should have some classes available from those. So you can see that there are a lot of things that I can use in my Kubernetes application. So I have MySQL from both providers, have PubSub, have Bigtable even, all these things. Okay, so this is more or less Kubeapps. These are the applications that I have deployed in my cluster. I can check a catalog of Helm Charts available from different repos. I can add my own private repo if I want. Most of them are coming from the community repo, some of them from the Bitnami one, some of them from Azure. And I can also check the available service instances that I have as part of the service catalog in my cluster. Again, this is namespace, so this is checking the default namespace right now. This is not going to be a fully live demo because these services take a while to provision, so I've done some work before. The first example is going to use Wordpress. It's going to deploy the Helm chart for Wordpress, but instead of normally the Helm chart for Wordpress is dependent on the MariaDB chart, so it deploys MariaDB in your cluster. But in our case, what we are going to do is we are going to use an Azure MySQL on the back end. I'm not going to use the completely upstream Wordpress chart, and I'll explain. I could, but I'll explain why I forked it and changed it a little bit. So you can see here that we have an Azure MySQL that was provisioned successfully, and I have a binding as well. And that binding has created, the action of creating the binding has created a secret. And this is an important bit. So the form, the schema for that secret, it's basically dependent on the implementation of the broker. So there is no standard. So it depends on the broker, it depends on the class, or in this case, in the plan. So you have to know beforehand through documentation from the brokers how those are going to look like in order to be able to connect your applications to those. So in this case, is how it looks like for Azure MySQL. So this is specific to Azure MySQL. So I have a secret with different keys, like database, host, password, username, etc. Again, I need to know that information in order to connect that WordPress. So I'm going to, and this is the way I've changed a little bit, so it's easier to connect. So I'm going to copy the secret name, and as I said, I'm going to work. I'm going to deploy WordPress. And I'm going to, is that big enough, the font? Okay. So basically what I'm going to tell it, and this is how I change, this is my fork, it's on my GitHub, you can change, it's basically just added a couple of values more that I say, okay, if I say that this is true, and I give it a secret name, and I'm going to say that WordPress has Azure as backend, and I'm going to tell it not to deploy MariaDB because I don't need to, because I'm going to use that instance. I think it's already a load balancer, yeah, so I click on submit. And it's going to start deploying. And while this is deploying, I'm going to show how this is done, basically, and the concept of having to know the keys of the secret. So this is how a Helm chart looks like. So you have a set of YAML templates that basically deploy your application. And this is the main one. So this is the one that creates the deployment. And basically what I've done is I added here an if that says, okay, if the value for the key Azure SQL is enabled equals true, so for MariaDB host, I'm going to do a secret key reference of the secret name as the secret that comes from the binding, and in this case, the key host. Same thing for the port number, for the database name, for the username, etc. So again, something that you need to know beforehand on, because it varies depending on the broker. So let's see how this is going. Okay, it's already running. So if we check the logs, you can see that instead of creating, well, we saw that we didn't have a MariaDB pod running because we tell it not to do so, and actually connected to the database. If we now check, the application should be deployed. We have our WordPress up and running using Azure MySQL. When you create, by the way, when you create those instances, for example, using Kubeapps, if you want to create a new one, you can select a plan, and the different plans have a JSON schema of the parameters that it expects. So let's put a name. So, and that we read that JSON schema over here. So again, Kubeapps is also a good way to do testing of these things because documentation is not great, and reading JSON schema yourself could be a little bit. So this is a good way to know what are the parameters that this service is expecting. Okay, so that's for the first example. The second one is very similar. It's a little bit same way. It's imperative. It's not declarative. In this case, it's Chart Museum, but I wanted to add it here quickly because it uses GCP instead of Azure, so we can have a couple of brokers of examples. So Chart Museum, if you don't know what it does, it's a very easy way to run a Helm chart repository on your Kubernetes cluster. And it allows you to use different backends for storage, like local storage or AWS or GCP that we just did. So in this case, we did the same thing. So we created an instance for GCP storage, so bucket storage. It was provisioned successfully. We created a binding. And the good thing about this binding, and therefore the secret, and that's why in this case I didn't have to fork anything. I just created the default chart museum chart repo, which is in the stable community repo, is that, well, it has a bucket ID, and then it has a JSON file in the private key data that has the default format for authentication to GCP services. So this is the JSON file that people connecting to GCP services expects. It's the same format all the time, so that's why the Chart Museum one is already ready for it. So this is already deployed. The reason why it's already deployed is because I'm using Chart Museum, this one, as a repo for my fork. So I had to have it already there. But if I click here in upgrade, I'm not going to upgrade it, but it allows you to show the different values that I provided. So basically I said, okay, for backend storage, use Google. This is the name of the bucket. I could have used the key instead of just copy and pasting, but the chart is not ready for that. So it doesn't have a reference. So I would need to fork that as well if I wanted to. But then at the very bottom, and this is ready from the upstream chart, I can say, okay, GCP authentication, it's in a secret. This is the name of the secret. And the key that contains the JSON to connect to it, it's called private key data. So that's another example. But that's not the best way to use the service catalog. So the best way to use the service catalog is using declarative description of your application. That's the main goal of the service catalog. So we are going to see quickly a couple of examples that do that. The first sample is going to be a mean stack, so Mongo, Express, Angular, etc. That is going to use Azure Mongo in the backend from Cosmos DB. So in this case, these are two different examples. The first example, the mean one, is that the case where you already have an instance, a MongoDB instance in Azure, and that instance, obviously, you can use it for different applications. So you don't have a binding yet. And the binding is something that you want to show as part of your, to create as part of your application. So the mean chart from Bitnami is already ready for this. So if I click and I create a deployment, so I'm going to say a load balancer so I can show it. So basically, I can say, okay, the DB is going to come externally. I'm going to use SSL. And it basically asks me for the service instance name that obviously I cannot remember anymore, so I'm going to copy that. This is the name of the instance. By the way, I'm going to say not to install a MongoDB because I'm going to take that from Azure. Click on submit. And it's going to start deploying my application. And as part of my application, is going to create the service binding. So if we go here to the MongoDB, we refresh here, you can see that it has created a binding as part of the description of my application. And probably this is already deployed. It's waiting for the load balancer. While this deploys, I'm going to check how that works. This is a Churn Museum one. This is a min template. As you can see, as part of the templates, now I have a binding. Again, this is an object in Kubernetes as part of the description of my application, but it has a service binding that I basically say, okay, the instance is this one that I put there. And then it's going to do the same thing, like using the different keys that I know the name of to connect to that database. So if that's deployed, so now I have my min stack to start creating my application backed up in Azure. And the final example, it's also declarative, is how you should do things here. It's basically a ghost block that is backed up by Azure. This is a chart created by Azure themselves as an example of these things. It's a fork from the original ghost chart. And it's on their Git repo as well. So let's try to find that one. And this one is going to do the full thing. So it's going to do creating the instance, then create the binding, and then connect to the application. So the chart is fully ready. So let's search for this one. This is on the Azure repo. It's going to do that. And basically, you don't have to do anything else because the defaults work for me. So it's going already the location, the service plan that I'm going to use. So I click on submit for that one. And if I go now to service instances, now I have here a new instance. This is coming from this deployment. You can see this provisioning. I didn't do anything. Is part of the application description. So this takes a while. So to provision one of these instances, it depends on the broker, it depends on the service. For this particular one, it takes about 10 minutes, 10, 15 minutes. So obviously, we are not going to show everything. But as you can see here, because it's part of the declaration of the application, it has created the object for the instance, the object for the binding. But obviously, the binding, it says error instance not ready. And what it's going to do, obviously this is a reconciliation loop. It's going to keep trying. And at some point, the provision will be successful. And it then will create the binding. And that binding, if you can see now, the deployment here. So you can see that the ghost pod is failing. It has a config error, so we are going to check what's going on. Not that one. So you can see that the config error is giving is that the secret that I referenced on the deployment is not found. The reason why it's not found is because the binding hasn't been successful yet, which is the object that creates the secret. But this is all on the reconciliation loop, so you can basically have your application as part of your CI/CD. It's going to deploy everything, and Kubernetes will keep trying until the instance has been provisioned, the binding has been created, the secret is created, and then it will start running your pod. So you can basically put everything on your CI/CD and forget about it. Okay, so this, quickly, this is the Helm chart for Ghost. Again, it's in the Azure GitHub repo. So you can see it creates a service instance as part of it with a type of class. type of plan, some firewall rules. This comes from the JSON schema that I was talking about of the required values. It will create a binding as well. And then it will do the same thing of using the different keys from the secret. So those were the 4 different examples. So we've seen those more imperative to more declarative. Basically, what I would give as takeovers is that the open service broker is a standard specification to deliver services. The service catalog is an implementation as a Kubernetes API extension for it. And basically that, in general, declarative is always better for Kubernetes. That's one of the key concepts. So hopefully the service catalog is still under heavy development. But this solution of many of the other solutions that are coming up will solve this issue of bridging the gap between the external services and Kubernetes. And that's it. Thank you.